Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing the concepts regarding lateral strain, longitudinal strain and Poisson's ratio. So coming on to the first concept of this lecture series, longitudinal strain. So what is a longitudinal strain? So here I have represented a schematic representation here. So here I have considered a body which is of length equal to L, initial length is equal to L and is subjected to the tensile load of magnitude equal to P both the directions. So as and when the body is applied with a tensile load in both the directions, so there will be increase in the dimension along the direction of the applied load. So this increase in the dimension along the direction of the applied load leads to the stress and also it results in the strain. So this strain when the body is subjected to axial or compressive load, there will be axial deformation along the length of the body. The ratio of axial deformation to the original length of the body is always termed as longitudinal or linear strain. So longitudinal strain is also defined as the deformation of the body per unit length in the direction of the load applied. So always the longitudinal strain or the linear strain both are same. Longitudinal strain is also called as linear strain. So longitudinal strain or linear strain is always obtained along the direction of the load application. So here along the direction of the load applied, P is the direction of the load applied which is along the length. So initial length you can observe here is L and final length is there will be increase in the length, that is it changes to L to L plus delta L since it is tensile load. So therefore delta L is nothing but change in length. So therefore longitudinal strain here is change in length to original length. So wherein change in length is delta L, original length is L. So delta L by L. So delta L by L is nothing but the longitudinal strain. So longitudinal strain, I repeat it, when a body when it is subjected to either tensile or compressive load, there will be axial deformation along the length of the load applied. So this ratio of the axial deformation to the original length of the body is known as longitudinal or linear strain. So always along the direction of the load applied, the strain which is observed is called as longitudinal strain. So whenever the nature of the load applied is tensile, then you can expect the longitudinal strain as increase in length to original length. But whenever the nature of the external load applied is compressive in nature, so you can expect the longitudinal strain as decrease in length to the original length. So coming on to the next concept, it is lateral strain. So here I just take the same example wherein here you can just observe here P is the load applied in both the direction with the same magnitude and tensile in nature. L is the initial length of the object and L plus delta L is the final length of the object. So as and when the load is applied along the length, you can just expect that there is an increase in the length along the direction of the load applied and simultaneously there will be decrease in the dimension perpendicular to the direction of the load applied. So I just repeat it. So when the body is applied with the load of some magnitude. So if at all, if the load is tensile in nature, so you can just expect the increase in the dimension along the direction of the load applied and decrease in the dimension perpendicular to the direction of the load applied. So whenever there is the decrease in the dimension perpendicular to the direction of the load applied, there will be resulting to the stress as well as the strain. So that strain corresponding to the decrease in the dimension perpendicular to the direction of the load applied is called as lateral strain. So here you have a rectangular bar of length L, breadth B and depth D, which is subjected to axial tensile load of P as shown in the figure. So here the length of bar will increase while depth and breadth will decrease, so which is just shown here in the figure. So initial length will be L and final length will be L plus delta L. So the initial width or initial breadth is B, change in width or change in breadth is B minus delta B, and similarly initial depth is D, change in depth is B minus delta B, D minus delta D. So therefore here lateral strain is equal to delta B by B or delta D by D. So here you can just observe the nature of the load applied is tensile in nature, wherein there is increase in the length and decrease in the other two dimension, that is decrease in the breadth and depth. So if at all, if the load nature of the load applied is compressive in nature, then along the direction of the load applied there will be decrease in the dimension, and perpendicular to the direction of the load applied there will be increase in the dimension. So this is the concept behind the lateral strain. So next, coming on to the next very important concept, that is Poisson's ratio. So Poisson's ratio is nothing but the ratio of lateral strain to the longitudinal strain is a constant for a given material when the material is stressed within the elastic limit. So this ratio is called as Poisson's ratio and is denoted by mu. So Poisson's ratio is the ratio of lateral strain to longitudinal strain within the elastic limit and is denoted by mu. So here it is also called as the ratio of transverse strain to linear strain. Here lateral strain is also called as transverse strain and longitudinal strain is also called as linear strain. So when the material is stretched in one direction, it tends to compress in the direction perpendicular to the direction of the force applied and vice versa. The measure of this phenomenon is given in terms of Poisson's ratio. So I just repeated, when a material is stretched, so it is shown in the diagram, you can just observe here. So when the material is stretched in one direction, so there is the linear strain which is observed along the direction of the load applied, and there is a compression in the perpendicular direction to the force applied. So this measurement of this phenomenon give rise to the terminology which is called as Poisson's ratio. So therefore Poisson's ratio is equal to mu, that is equal to lateral strain to longitudinal strain. So it is the ratio of transverse strain to the longitudinal strain in the direction of stretching of the force, and this can be stress and strain relation that is generated with the application of force on the body. So if at all, for tensile deformation, always Poisson's ratio is positive, and if at all if there is a compressive deformation, the Poisson's ratio is negative. I just repeated. So for a tensile deformation, always the Poisson's ratio is positive, and for the compressive deformation the Poisson's ratio is negative. So here the negative Poisson's ratio suggests that the material will exhibit positive strain in transverse direction, even though the longitudinal strain is positive as well. So I just repeated, when there is the negative Poisson's ratio, it suggests that the material will exhibit the positive strain of positive strain in the transverse direction, even though the longitudinal strain is positive. So for most of the material, the Poisson's ratio lies with the range of 0 to 0.5. So here you can just observe mu is a Poisson's ratio. So lateral strain is equal to mu times of longitudinal strain. So and lateral strain is equal to minus mu times of longitudinal strain. Why I have taken the negative sign convention here is, as the lateral strain here is in the opposite in sign to the longitudinal strain. Why? Because lateral strain here, as in this case for the tensile load, it is for the decrease in the dimension, so I have taken it as negative. So therefore lateral strain is equal to minus mu times of longitudinal strain. So this is for the tensile load. So this is for the tensile load. So thank you for watching. Please like, share and subscribe the video. Thank you.